All right, so today I am covering discount and markup problems. So these are specific types of problems involving percentages where you're finding the discount of something, or the discount, you're trying to find the original price, or if something's marked up in price, which could also include things with tax being added on or tip and things like that. Those are also considered markup problems. So these are specifically word problems that involve very common things that you see in life, and I discovered a lot of people tend to actually do these wrong, which is that's important to know, because if you're calculating the discount incorrectly, then you might think when you're at the checkout line or something that there's something wrong, that it wasn't done right, but maybe it was your calculation that was incorrect. So to start off, there is a general problem solving procedure when you're solving word problems. And so the first step is to read the problem carefully. And when I say carefully, I mean carefully, because there is a difference between percentages of saying like 10% of something and 10% off something. It's a difference of one letter, but it's a big difference when it comes to the math that you're doing. So you do need to read the problem very carefully. For percentages, I don't normally draw pictures or tables, but I do write down the information that I know and try to piece it together. Then once you've read through it, you start assigning variables, the things that you don't know that you're trying to find out. And then once you've kind of decided, okay, let's say I'm trying to find a percent, so I'll say P is my percent. Then if there are other unknowns, you try to write relationships between them. And so usually for what we're doing, we're usually writing only one equation, but sometimes there's two. And sometimes it helps to actually rewrite the equation in words and then turn it into an equation versus trying to do the equation right away. Because sometimes you'll get the information in multiple sentences and you have to take that information, combine it into a single sentence, and then that sentence gets translated into your equation. And so that's less true for percentages, because solving problems with percentages have a formula basically to use, but it's a general skill with other types of problem solving and word problems. Then once you have your equation, you solve for whatever your unknown is, and then you should check your answer. So first, check to make sure it works in the equation that you wrote. And if it does, you also have to then say, well, does the answer I have make sense? And does it actually answer the question that I'm looking for? So as an example, I was actually grading for my pre-calc class today, and one of the submissions, they were finding out how many liters of like a 10% solution they needed to make a certain mixture. Mixture problems are actually covered in our class. I think it's in the reading, and they got a negative answer. And so, the answer solved their problem, their equation, it worked in their equation, but getting a negative for an amount doesn't make any sense. So you have to, you may get an answer that works in your equation, but if the answer doesn't make sense, then that tells you your equation was wrong, that your setup was wrong. So that student had the equation incorrect, and that's why they got an answer that didn't make sense. They checked their work and it worked in the equation, but it didn't make sense. So when you're doing word problems, you have to also consider, does the answer I have actually make sense? Because if it doesn't, then that indicates something else, that maybe I did my algebra right, but my original setup was wrong. And then, make sure you're actually answering the question that's asked. Sometimes you'll get one answer and that's not actually what it's looking for. You have to do some extra steps after that. And then the very last thing is to state your answer to the problem. When there's word problems, we like to give our answers in sentences and in context. So you're not just saying the answer is X equals 2. You need to actually give a context, like the amount of discount was 2% or something like that. Like writing a sentence, you're including units, you're referring your number back to what you're actually trying to figure out. Like you're basically rewording the question as a sentence. It's like doing Jeopardy backwards. Backwards, they give you the sentence and then you're asking the question. Here you're doing it the other way around, is you've kind of answered the question, now you want to write it as a sentence. So that's the general procedure for problem solving. And this is basically what you follow for any kind of word problem, including these markup and discount problems. So since we are going to be working with percentages, we want to go back to what the definition is of a percent, what that actually means. So the word percent literally means per cent, like you split it up into two words. The word per means divide, and then cent means 100. You think we have 100 cents in a dollar, 100 pennies, cents is our decimal version or whatever. 1 penny is 1 cent. So there's 100 of them in a dollar. Centuries have 100 years. So that word cent means 100. So it literally means divide by 100. And that's what a percent is you've got something that you divided by 100. So when we're solving problems with percentages, there are two general ways that you can solve these types of problems. So there's the first way, which is actually the way that the textbook uses, is that you have some amount and then it's equal to the percent times what they call the base. And when you use that formula, whatever you use for the percent, you have to convert it to a decimal first. So you have to divide it by 100. Way two, you are writing it instead as a proportion by basically using the definition of a percent. So you think of a percent, it's part out of a whole. Like if you have 50% of something, you have 50 out of the whole thing, which is 100. So you're thinking of it in terms of like a fraction, part of a whole equals your percent over 100. And when you use the proportion method, you don't have to convert it to a decimal. You can put in the actual number that you have for percent because the divide by 100 is already taken care of there. So when we're going to be solving these markup and discount problems, we can use either one of these methods. And I'm actually going to show both methods because I think it's important to be able to choose the one that you think makes the most sense to how your brain works. I do think that one is better than the other in terms of having fewer mistakes, but it's up to you. It's both of them will work. So we're going to start with the situations where you are increasing by some percent. So that would be sales tax. It's increasing your price. A markup, as you're increasing what you're selling it for. Tips, as you're increasing your bill by adding a tip into. So these are all adding percentages. So I prefer the proportion method. And so the way that I set this up is that I've got my new price over the old price. So that's sort of like your part out of the whole, is we're comparing it to the whole thing. We're comparing it to the original price. So the new price is on top. And we have 100 in the bottom right because that's the setup for the proportion. And then to indicate that you're adding this percent, you're adding 100 to the percent. You're paying the original price, which is 100%, and then you're adding new percentages on it. So that's why it's 100 plus a percent. So the new price is higher, so that needs to be across from the part that has the higher number on the right, because we're adding to our original price here. Now the textbook has this formula that they have the original cost plus the markup equals the markup price. And they don't actually state this. The textbook does an example of a discount and they do state the discount one, but they don't actually give you the formula for markup. They kind of expect you to do the discount and then know that the markup is similar. But it's like you have your original cost plus how much money you're marking it up by, and then that's the total price after it was marked up. So if you translate this into a actual equation, you can write it as x plus px equals y. So x is the original cost, and then p is the percentage you're marking it up by. And so for the markup, you're finding that percent of the original cost. So that's why they're multiplied together. And the word of means multiply. And then that equals your new price, the marked up price. So we're just using a different variable for that Y. And this would also work for tax, for tip, anything you're increasing. So we've got the method on the left, which is using a proportion, and then the method on the right, which is using this formula. And I prefer the left method because I find there are fewer mistakes. I see people making mistakes when they try to use the method on the right. So personal preference, that's why I use the proportion, but I will show both. So first example here. A drill is on sale for $99.99. If the sales tax rate is 9%, how much will Molly have to pay for the drill? So we're adding tax. We want to know the price after tax. So the method, the proportion method, you basically have your new price, which we're going to call, we should actually are going to call that the after tax price. And then we're going to have the original price, which is this, whatever it's on sale for here. And then this is equal to 100 plus your percent divided by 100. So that is the format that we will be using here. And so we are looking for how much it is after tax, because that's what she's going to have to pay for. So we need to pick a variable for that. Most people pick X. So our unknown is the amount after tax. The original price is how much it was before tax. So that's $99.99. And then we have 100 plus our percentage. So that's plus 9 divided by 100. So we've got this proportion that we're setting up. And so the first thing I want to do is just on the right side, I can do the 100 plus 9. So I have X over 99.99. Well, that's 109 over 100. Now to solve for X, we have X divided by 99.99. We want to get rid of that fraction. So we are going to multiply both sides by 99.99. And that will get rid of that fraction there. So we're left with X. And then on the right, we've got 109 over 100 times 99.99. And basically, you're just going to do that on your calculator because these are, it's a real problem. We're not going to deal with fractions. We can just literally do that on the calculator. And we're going to get an answer in money because it's in dollars. So we want 2 decimal places. So you can just do 109 divided by 100. And that gets you the part that was the fraction. Then you multiply that by 99.99. And that gives us, if I round it to 2 decimal places, $108.99. And then so you get this answer and you want to say, okay, does this make sense? We have added, so our original price was about $100. And if sales tax rate was 9%, that's close to 10%. 10% would be moving the decimal place. So it'd be about $10. And so it looks like we added about $10 to the price. So that makes sense. That's close to what you would have if the sales tax rate was 9%. So just kind of estimating and rounding, you can say, does this number make sense? And it's larger than what it was, which makes sense because we're adding on sales tax. So 108.99 makes sense based off of what we know. So when you actually write your answer, you would say Molly will have to pay $108.99. So notice that the question was, how much will Molly have to pay for the drill? And I'm basically rephrasing that. I could even say, I can even be more specific and say for the drill. So that I'm using most of the words there. So Molly will have to pay $108.99 for the drill. So I'm taking that answer and putting it into context, making it, explaining what that answer means in context of the problem that we have. So before I move on to solving it the way that the textbook does, are there any questions? Okay. So the way that the textbook would do this is that it would have the original price. You're adding on tax, and then that is your after tax amount. But the problem, and this is why I don't particularly like the textbook method, is that they don't give you the dollar amount of tax. So you can't just add 9% to 99.99. You'll actually get close here, but that's not the that's not the correct procedure. It won't work for every situation. It just happens because of the numbers that it will actually work in this case, but that's not really what you're supposed to be doing. When it says plus tax, it's the tax in dollars that you're adding on. And so when you're not given that, so you have to kind of think about, well, what does it mean to find tax? And so, well, to get the amount of tax, you're taking 9% of the thing that your original amount. So you have that amount for tax is 9% of the 99.99. So you've got like an intermediary step to kind of do here. So you have your tax is going to be 9%, and you have to convert it to a decimal. So I should write this in words first. 9% of the original price. So this is what I said about you're kind of taking multiple sentences and rewriting it into a single sentence that you can translate. So that means our tax is 9%, so you convert it to a decimal. The word of means multiply, and then we plug in our original price. So we take 9% of the 99.99. And so we get 8.9991. And this is dollars, so this is rounding to about $9. Then you go back to your formula, original amount plus the tax amount equals after tax. So then we have our original, which is $99.99, plus the amount of tax here, which is $9. And then that gives you your amount after tax. And so you're just adding those together. And we get the same answer, $108.99. So the method on the left is you're just kind of plugging into a formula. The method on the right, you're kind of thinking through what exactly is going on. And then you're making multiple formulas and kind of plugging it together to get your amount. So you have to kind of translate what it means to find tax, which is 9% of the original. And you have to know that of means multiply. And then you're adding that tax back onto your original price, and that gives your amount after tax. If we use this formula here, I might have to get my pen. There we go. My pen slightly was temporarily not working. You would just be basically doing 99.99 plus 0.09 of 99.99 equals whatever you're looking for, your Y. Or another way to look at it, it's 1.09 times 99.99 because you're adding 199.99 plus a 0.09 of it. So that's how those would be kind of add together. For a problem like this, if I want to find the amount after tax, and I'm in the real world, I will actually not use the proportion method, but I won't really use the textbook method either. I will use what I have in green in the lower right. I'll just know that if I'm adding 9%, then I'm adding that to 100. And so I start at 1 and then I add 9% as decimal, and then I multiply that by my original price to get the new price. And so that's 1.09 times 99.99. And that actually is the same what we have with the proportion method here, because 109 divided by 100 is 1.09. So shortcut, I usually just do what's on the right. But long step way is you've got the proportion on the left, or you have what's in the blue where you're doing it in multiple steps. Now, the downside of using the blue or the green is that I frequently see students trying to use those methods in the wrong direction when you're given the after price and you're trying to find the original. So they'll try to do something similar and just do subtraction instead of adding. But they'll still multiply whatever their price is by the percent and then try to subtract it off. It doesn't work that way. Percentages don't work that way, and you will get the incorrect answer. And I see probably about 75% of people doing a problem like that on a quiz or exam getting it wrong because they're trying to use the textbook method and work it backwards. And it doesn't work that way, which is why I prefer the method with the proportion, because you're less likely to make that mistake. So this is an example. Let's see, actually, let's do this one and then I'll go back to the next one. This is an example of a problem that tends to be done incorrectly if you attempt the textbook method, because people put their numbers in the wrong spot. So we've got in one area, the cable company marked up the monthly cost by 6%. The new cost is $63.60 per month. What was the cost before the increase? So I'm going to do this with my proportion method. We have our new price, basically over the old price. It's 100 plus your percent over 100. So you take the information that you have and you plug it into this formula. We know the new cost is $63.60, and we are looking for the old cost. So that's going to be X in the denominator. On the right, we have 100 plus the markup, which is 6%, and then over 100. So we get 63.60 over X equals 106 over 100. So unlike the last problem we did where our unknown variable was on the top of the fraction, now it's in the bottom. And when it's in the bottom, we do what is called cross multiplication, where you multiply the diagonals and then you set them equal to each other. So x times 106, so that's 106x. That's one diagonal. And then you do that with the other diagonal, 63.6 times 100. And so now you have something that you can solve for x. So we're going to do the multiplication on the right and then divide by 106 and get our answer for x. And you can actually just show that by dividing by 106 first. So we would have our 6360 times 100 divided by 106. And so you just do that on your calculator. And just kind of do it in that order. And this actually comes out to a nice whole number, $60. So we go back to the problem. It says, what was the cost before the increase? So the cost was $60 before the increase. So we're taking that answer and then we're putting it back into context, kind of parroting what the actual question was. So let's see what happens if you try to use the textbook method, because this is where people tend to get confused. And so, I would say while you're, just kind of think about how would you set this up? So the textbook method is that you have your original price. And in this case, instead of tax, it's going to be markup. And then it's going to be your new price. And so people are inclined to say, okay, the markup must be 66% of 6360. But that is not actually what it is. The markup is your 6% of the original price. And we don't know the original price. That's what we're looking for. So if you start using X for your original, you get your markup as you take your 6%, make it a decimal. Of means multiply, and then we're going to use X because we don't know the original price. So then you go back to our problem here that the original price plus the markup is the new price. The original price we don't know. Our markup is 0.06 times the original price. And then we do know the new price, that's 6360. So if you're trying to do this problem on, on your own, think about how would you set this up? I bet you that this is not how you would set it up. You would not think to do it this way. And you would probably do 6% of 6360 and then try to subtract it off. But if you notice here, you don't actually have any subtraction going on. When we add our like terms, that's a 1x. So we get 1.06x equals 6360. So there is no subtraction in this problem at all to find out what the original cost was. And that's where people go wrong, because we added to get the new cost. So they think let's subtract to get the old cost, but it doesn't work that way. If you follow the percentages, that's not actually how it works. When we're solving this, we're dividing. We're going to be dividing by 1.06. And so you get X equals, and we'll just verify. Yes, that gets $60. You get the same answer. So this is the difference between the instructor method and the textbook method. And this demonstrates why I prefer the proportion method, the method on the left. Because the method on the right, when people try to do it from memory, trying to remember, well, this is what the formula is, you know, they set it up wrong and then they end up subtracting and just things go wrong. So are there any questions either on the left or the right here, or maybe on the textbook method in the other example that I did with the tax? Okay. Well, this one I had skipped because I was kind of going with where my explanation went. So this is also still, we've got another markup kind of thing here. This is an actual markup problem. So during its first year, a gaming console sold for $425 in stores. This product was in such demand that it sold for $800 online. What percent markup does this represent? So what percent did we add on to the price? So we're looking for what percent markup does this represent? And we're going to round to the nearest whole percent. So it tells us where to round. So with my handy proportion, we have our new price, which in this case is going to be the marked up price. So that will be the online price, divided by the old price, which is going to be the store price. And then it's 100 plus your percent divided by 100. So in this case, we know the online and the store price. So we know the new price and the old price. We're looking for the percentage. So we've got 800 over 425 equals 100 plus, and then that percent is what we're looking for. So I'm going to just make that X over 100. And so now we're going to solve this for X. So we can do the 800 divided by 425. Because this is a real problem, we don't have to worry about trying to get the fractions or anything like that. Just divide it. And it's going to give us several decimals. So it does say at the very end, we're going to round to the nearest whole percent. We're going to have lots of multiplying to go on here. We're going to be multiplying by 100. So I would not round right away. It's like when you do 800 divided by 425 on your calculator, you get 1.882352941. You get lots of decimals. So to try to avoid rounding too soon, which then if you're doing a problem like this in Connect Math, if you round too soon, you round too much, you can get the answer wrong, even if it's close, just due to rounding. So what I recommend doing to solve this is to just multiply both sides by 100 to get rid of that denominator. So we did that in our first example. And so we're going to have 100 times 800 divided by 425 equals 100 plus X. So we're basically getting rid of the fraction and we're left with only what's on top of the fraction, the 100 plus X. If you want, you could do the cross multiplication method that I did in this example, but then that has some distributing and sometimes that confuses people. So I like to do it this way. And then you're just on your calculator going to do that 100 times 800 divided by 425. And then this is what we're going to round to a whole number. So just if you're going to round, do it after you multiply by 100. So we get 188.2352941. So we'll just round to 188. And then this equals 100, oops, plus X. And so then you're just solving for X. So you're just subtracting 100. And we get for our final answer, 88. And that is our percentage. That's what we're looking for. So this is an 88% markup. So this is an 88% markup. And so you want to think, does that make sense? So a 100% markup means you're doubling the price. You're taking the current price, you're adding that same thing, 100% of it back on. So you're doubling. So 800 is not quite double 425, but it's about like if it was 400, it doubles to 800. So having 88%, having a percent close to 100 makes sense. So again, you want to look at this and say, does this make sense? And 88% does make sense because it is roughly double in price. So that's how I would solve a problem like this using the proportion. So textbook method. So we're going back to that they have the original price, which in this case is going to be the store price, plus your markup is equal to our online price. And the markup is equal to some percent of our store price. And we don't know what that percent is. And we don't really know what the markup is. So we just know that the markup is some unknown percent. And so this is where things get a little tricky because we have to write this over 100 because we don't actually have a number there to convert to a percent or to convert to a decimal. When it's a percent, like here, 6%, we had to divide it by 100 to get the decimal in the formula. But we don't have an actual number there, so we can't literally divide it by 100. So you have to just write that you're dividing by 100 or just making it a fraction here. And then of the store price, so that we know what the store price is, that's $4.25. So we've got this kind of thing with, we've got 425, we've got this divided by 100. I can at least simplify and do 425 divided by 100. And that will give us 4.25x. So the amount of markup is 4.25x. So once you figure that out, now you're going to be putting it back into this formula. So our store price was 425 plus 4.25x equals the online price, which is 800. And so now you are solving for x. So I'm going to subtract 425 from both sides. So we have 4.25x equals 375. And then you divide both sides by 425. 4.25, I should be clear. So that's 375 divided by 4.25. And so we get, it's like 88.2352, you know, it's got all these decimals. We round it to a whole number, we get that 88 back. So you do get the same answer. So again, this is another reason why I prefer the proportion method. Because I feel like with the proportion method, the only numbers you really see are the numbers that you're given in the problem. 800, 425, and we got 188 that we were solving for, but they weren't like crazy numbers. But when you're doing the textbook method, I feel like you get to a point where it doesn't really make sense anymore, because then you're looking at it and you're like, well, why am I multiplying the percent by 4.25 if X represents my percent? Like, why 4.25? You're getting, and then you end up with a 375 that's like, not, it just seems like the numbers are less intuitive by doing the textbook method versus the instructor method. The instructor method might be slightly harder to solve because you've got things with fractions, but I feel like as far as the risk of getting the wrong numbers is less. With the textbook method, once you get it to set up correctly, solving's fine, but it's the struggle is getting it set up correctly, and that's where you're prone to make mistakes. So there are questions. Do you prefer one method over the other method out of these 3 examples that I've done? I think the instructor's method is easier. That's good, because that's what I think is easier too. So that's why I prefer to teach it that way. So I've got 2 more examples, and these are going to be for the discounts. And so you'll see it's very similar in setup. It's just now everywhere where you had adding for a markup or a tax or a tip or whatever, you're now subtracting. So my method, the proportion, is the same thing. It's just instead of 100 plus, it's 100 minus. The textbook method, again, looks almost exactly the same. It's just now you're subtracting the discount. So the issues that you have with the methods, like with it adding, where it's like the textbook method, you have to do multiple parts, you have to make sure you're putting numbers in the right spot, they're still here because the formula is almost exactly the same. And what I usually find people doing is, they end up adding where they should be subtracting. It's, they add when they should multiply or things like that. So we'll do both of these, the instructor's method. I do have it set up for both methods, but we'll do the instructor method for both of these examples, and then we can see how much time we have left off from there. But we've got a hands-free kit for a car, costs $62. An electronics store has it on sale for 12% off with free installation. What is the sale price on the hands-free kit? And then what is the discount? So we've got, in this case, the new price. It's always, the new is always what happens after you do the percentage. So in this case, the new price is going to be the sale price, the cheaper price. And so always just remember that the original, whatever you're starting with, is at the bottom. And then, so if you can't remember which percent goes where, it's like the final is on top, the original's on the bottom. And now for discount, you're subtracting your percent. So we have 100 minus the percent over 100. So we are looking for the sale price. So that's going to be X. The original price is $62. And then this is 100 minus your percent. So we're subtracting 12% and then dividing by 100. So this is where it gets a little weird for people, because people, the subtracting 12%, whatever you're subtracting your percent, usually gets to a point where it's no longer intuitive. So we end up with X over 62 equals 88 over 100. And you might think, well, where does that 88 come from? And so if you are if you have 100% of something and you're removing 12%, then you have 88% remaining. And so that's really what discounts are doing, is they're removing percentages so that you have a different amount remaining. And that's why we have this 88 now. So sometimes I'll see people try to do 12% and then subtract the dollar amount instead of subtracting the actual percentage. And it doesn't quite work that way. But if you set it up with a proportion, you don't really think about any of that. You just plug in your numbers and do the math. So I'm going to just multiply both sides by 62 so I can get rid of that denominator, and then we can just kind of do our math all in one step with the calculator. So we've got x is 88 over 100 times 62. So just divide 88 by 100, then multiply by 62. And we get 54.56. And so this is money, so 2 decimal places make sense. So we have to go back to the question. There are 2 questions here. First, what is the sale price on the hands-free kit? And then what is the discount? So we just found the sale price. So the sale price is 54.56. And I'm going to include my dollar sign to give it units. Now, when it's asking for discount, it wants the dollar amount of the discount. So all you need to do is subtract and do 62 minus 54.56 to find that amount. So our discount is equal to 62 minus 54.56, which gives us 744. So the discount is $7.44. And if you were doing this like on the fly, an alternate way to find that discount is to take your original price, 62, multiply by the decimal percent, the 12%, and then you get 744, and then you can subtract it away. So this is an example of a problem where the textbook method is more likely what you might actually do in real life, where you're finding 12% of the price, and then you would subtract it away. You get the same answer either way. And that's totally fine. If you were, with a discount here and you want to know what the sale price is, whenever you're looking for the price after something, it's easy enough to do the textbook method or just to kind of multiply with percentages, because people don't usually mess that up. It's when you're asked to find the original and you're given the final one, that's usually where the things go wrong. So here's an example of that. We've got a Blu-ray disc is on sale for $18. If this represents an 18% discount rate, what was the original price? So we have our sale price over the original price. And then it's going to be 100 minus your percent over 100. So we're given the sale price, which is $18. We don't know the original. And then we have 100 minus 18, and that's the percent 18, not the $18, over 100. So you do 100 minus 18. So that's 82. So we're going to get 18 over x equals 82 over 100. And so this is where I do my cross multiplication. I'm going to multiply x times 82. And then we'll do 18 times 100. And then just because I like to do all these calculations all at once to avoid rounding, I'm going to divide both sides by 82. So this gives me x is going to be 18 times 100 divided by 82. And you can just stick that in your calculator. And so we get 21.9512. We get all these decimals, but you round it and it's 21.95. So $21.95. So that is the original price that we just solved for. So the original price was $21.95. So I'm going to just demonstrate where people usually go wrong so that you kind of see what, oh, I don't know if that purple's not going to show up. Just to demonstrate it, is that what I will often see people do is take 18% of the $18. And that gives you $3.24. And then they will add that back onto the 18. But that actually gets you a different number, 21.24. And you might say, oh, but it's close. It's close when you have small numbers. But if you have big numbers, like if we were talking about $500 and an 18%, the difference gets larger and you get way off. Like in my college algebra class, they actually had a question like this on their quiz that I'm grading for this week. So there's a lot of overlap between my classes this week, but I was grading a quiz and I saw somebody who did this problem with the wrong method, and the correct answer was like 300 something and they got 900. Like it was a huge difference. So that's why I like the proportion method, because if you just stick with it and you put the numbers in the right spot, you will get the right answer every time, because you're not changing how you set up the problem. It's just the only thing that changes is where does X go. If you do the textbook method, you are kind of changing how you're doing the problem, because like in this situation, multiplying by the percent works. And then you could like subtract it. And so you might think, oh, multiplying, adding it back on will work, but it doesn't work. The method is completely different when you're trying to use the textbook method. You can't just use the same method and then change it to a plus, because it doesn't work. But if you use the proportion method, you don't have to worry about that. You just change whatever your unknown is, and you just go with it. So, and a problem like this is going to be on the quiz or the exam. We specifically put this type of problem on it just because this is where people usually make a mistake. And so we want to make sure that people know how to do it correctly, because, this is something that relates to everybody in real life, is understanding that you're doing your calculations correct with discounts and finding out what the original price is and all that kind of stuff. And this is where algebra is handy, because if you try to do it mentally in your head, you might do the wrong method. So, but if you follow the algebra, you get it right. So are there any questions? Okay. So that's all I have.